Hello, my name is David Burns with Akzo-Nobel Coatings. Over the next several minutes, I'm going to explain how you can improve the energy efficiency of a home or other building with a painted metal roof, or what is specifically referred to as cool metal roofing. Metal roofing is gaining in popularity year after year, and one reason is the effect it has on reducing energy costs. Studies conducted by various federal agencies and independent organizations conclude that a cool metal roof can reduce the energy costs associated with cooling the interior of a structure by up to 20%, and reduce peak cooling demand by up to 15%. It should be noted that any loss of residual heating in the winter that might result from using cool metal roofing is minimal and is more than offset by the difference in the cost associated with cooling a structure versus heating. As a result of these properties, the federal government's Energy Star program includes metal roofing that meets certain criteria that I'll address in more detail later. In just a few minutes, I will demonstrate how Akzo-Nobel's cool chemistry reflective coatings can reduce a roof's surface temperature and the impact that that has on the interior space. But first, we need to talk about the solar concepts that are involved. Ultraviolet light, which is responsible for sunburns and causes colors to fade, is about 5% of the spectrum. 46% of the sun's energy consists of visible light, and it is the portion that determines the colors we can see. The largest area of the spectrum is infrared energy, which is invisible and produces the heat we feel and is therefore of most interest to this discussion. There are two important concepts to consider when talking about cool roofing: solar reflectance and thermal emittance. The more important of these two is solar reflectance. This is the percentage of solar energy that is reflected away from a surface. The higher the solar reflectance value of a material, the more solar energy that is reflected away from it. In the case of roofing, that means the higher the solar reflectance value, the greater the amount of energy that is reflected and the less heat energy that transfers to the interior of the building. Traditional asphalt shingle roofs have a solar reflectance of around 10 to 20%. Whereas cool metal roofs have a solar reflectance of up to 70%. That means that a cool metal roof could reflect up to 70% of the sun's energy away from the surface, and only 30% is absorbed. Shingles, on the other hand, will absorb 80 to 90% of the sun's energy. The high solar reflectance of a cool metal roof translates into less heat transfer to the interior of a structure and less energy used for air conditioning and other cooling methods. The other related concept is thermal emittance. Thermal emittance is a measure to express how readily an object gives up stored heat energy. It has been clearly established that painted metal roofing is a very good performer in this regard. You want the highest possible thermal emittance along with the highest possible solar reflectance. And Akzo-Nobel Cool Chemistry series of coatings provide you with both properties. Akzo-Nobel's Cool Chemistry series of coatings are designed to comply with Energy Star guidelines for steep slope roofs. This designation means that you can rest assured that our products will help lower your cooling costs and also be good for the environment. Most people are familiar with the Energy Star program, which has been around since 1992. Starting in 1995, the federal government extended Energy Star certification to building products and individual structures. The program has expanded to involve scores of manufacturers and builders that are certified Energy Star partners. Energy Star rated cool roofing products help reduce urban heat island effects, pollution, and greenhouse gas emissions. Now that I've described the concepts behind our Cool Chemistry series of coatings and what it can do for your energy costs, I'm going to illustrate what cool roofing products can do through a demonstration. With our Cool Chemistry series of coatings, the paint formula is optimized to achieve higher solar reflectance. As we discussed earlier, solar reflectance is the percentage of solar energy that is reflected away from a surface. The higher the solar reflectance value of material, the more solar energy that is reflected from it. It should be noted that the improved reflected qualities of our Cool Chemistry series are achieved without compromising long-term performance. One way to illustrate the difference Cool Chemistry makes is to simulate a solar exposure situation and measure the surface temperature of various materials, which we'll do with some heat lamps and an infrared thermometer. The first demonstration we will do is between a Cool Chemistry series white and a standard pigmentation dark brown metal roof. The white sample on the left has a solar reflectance of 0.72, which means that of all the solar energy that hits the surface, 72% of it is reflected away and never absorbed. The dark brown sample on the right has a solar reflectance of 0.13, which means that only 13% of the solar energy is reflected. We'll give the metal a few minutes to heat up, and then we can measure the temperature of each. Okay, it's been 5 minutes, so let's take a look at the surface temperature of these samples. Reading the Cool Chemistry series white sample, we have a temperature of 109 degrees. Next, let's measure the standard pigmentation dark brown, where the surface temperature is 150 degrees. So in just 5 minutes, the white exhibits a surface temperature 41 degrees below that of the standard pigmentation dark brown. For the next demonstration, we will look at the improvement in solar reflectance between a Cool Chemistry Series sample and a standard pigmentation version. Both are the same color, but have different solar reflectance values. The sample on the left is a Cool Chemistry version, which has a solar reflectance of 0.28. That means that of all the solar energy that hits this, 28% of it is reflected off and never absorbed. The sample on the right uses standard pigmentation, same color, but only has a solar reflectance of 0.13. So in this case, 13% of all the solar energy that hits it is reflected. In this example, we have two pieces of the same color, but one is more than twice as effective in terms of energy efficiency. Okay, it's been 5 minutes, so let's take a look at the surface temperatures of these samples. Reading the Cool Chemistry sample, we have a temperature of 112 degrees. Next, let's measure the standard pigmentation version, where the surface temperature is 150 degrees. So in just 5 minutes, the Cool Chemistry product exhibits a surface temperature of 38 degrees below that of the conventional coating. What we have been demonstrating so far is surface temperature, and now we turn to the condition of the interior space that we want to keep comfortably cool while consuming the least amount of energy. By understanding solar reflectant values and the relationship with thermal emittance, you can imagine what sort of effect roofing material has on attic temperature and in turn the living area temperature. If less heat builds up in an attic, there will be less heat transferred to the finished living area. To demonstrate this, we have built units designed to represent a building's attic space, which have been heating up while we've been going through the earlier demonstrations. Starting on the left, we have a brown metal roof with Cool Chemistry technology that registers a solar reflectance reading of 26%. The middle unit represents the same brown color using standard pigmentation with a solar reflectance of 10%. Finally, on the right are standard asphalt shingles that have a solar reflectance rating of about 10%. Each of these materials have been subjected for several minutes to the same type of heat lamps we use when evaluating surface temperature. Inside each structure, we've placed a thermocouple to measure the interior air temperature, with the readings displayed on a monitor. As you can see, the attic space under the roof panel with the Cool Chemistry coating is recording a temperature of 113.1 degrees. The interior space under the standard pigmentation panel is registering a temperature of 159.5 degrees, while the attic space covered by the asphalt shingle exhibits a temperature of 159.2. Cool metal roofing has many advantages, from energy efficiency to being environmentally conscious. Metal roofing is very sustainable, containing significant recyclable content, and is also 100% recyclable if replaced. It lasts much longer than other roofing types and is very durable by being resistant to wind, hail, and fire. I hope that after viewing these demonstrations, you can see the potential energy savings that come from installing a cool metal roof. Energy costs for cooling can be reduced by up to 20% and peak cooling demand by up to 15%. These savings are realized through the pigmentation in our Cool Chemistry series of coatings that work to increase the amount of solar energy that is reflected off the roof. The energy savings that can be achieved are real, and through Energy Star, the federal government is working hard to promote energy conservation. If you can keep your attic temperatures approximately 46 degrees cooler, you're going to save some money on energy, especially if air ducts are in the attic or if the attic is poorly insulated. Thank you very much for your time, and I hope this has answered any questions you might have had about the benefits of cool metal roofing.